Hello friends, Mr. Burrell here. We're in the middle of Unit 5. We started off talking about rational expressions, and we've talked about simplifying different kinds of rational expressions, and we've talked about excluded values that are associated when we're simplifying rational expressions. In section 5.3, we're going to talk about adding and subtracting rational expressions. So just like in Unit 3 when we were talking about like adding and subtracting polynomial expressions, now we have these different kinds of polynomial expressions in rational form, so written as fractions. We're going to talk about how to add and subtract those kind of rational or fraction written expressions. So this will prepare us to next be able to solve equations that are of a rational nature. Rational equations, or equations that are in the form of fractions. So by the end of this lesson, this is what I want you to be able to do. I want you to be able to find a common denominator for two rational expressions, add rational expressions, and subtract rational expressions. So we're going to talk about finding a common denominator, and then adding rational expressions and subtracting rational expressions. So let's get to it. Okay, some definitions. A common denominator is a shared multiple of the denominators of several fractions. So we'll look at some examples of these on the next slide, but to find the common denominator, the least common denominator, put all the included denominators in factored form. So for example, right here I give you the instructions to add and subtract each of the rational expressions and state the excluded values. So let's do a quick reminder, a quick recap in our minds here of how we just add and subtract fractions in general. So previously, in the previous section, we were talking about multiplying fractions. So if I had like 2/3 times 4/7, I just multiplied straight across. 2 times 4 is 8. 3 times 7 is 21. When I'm multiplying fractions, I just multiply straight across. When I am adding fractions, so if I was taking 2/3 plus 4/7, I need the denominators, or the bottom of these fractions, to be the same. In order to add fractions, I have to have a common denominator. Okay, I can't just add these. 2 plus 4 is 6, 3 plus 7 is 10. 2/3 plus 4/7 is not 6/10. You can check that in your calculator. Check that in your logic brain. That doesn't work. That doesn't even make any sense. So before I add fractions together, I have to have a common denominator. So look at example number 1. I have 3/4 plus 3/4. I already have a common denominator. So when I have two fractions with a common denominator, I leave the denominator the same. And I add the numerators. So in this case, I have 3 plus 3, which is 6, and then the denominator stays the same, so that's 4. So 3/4 plus 3/4 is 6/4. Or if I were to reduce that, simplify that, like I talked about a couple of sections ago, I could divide the top and the bottom by 2 and be left with 3/2. So 3/4 plus 3/4 is 6/4, or if I reduce that, 3/2. Because when I add and subtract fractions, I need to have a common denominator. So let's look at example number 2. I have 3/8 minus 1/4. Well, here I don't have a common denominator. The number down here is not the same. So before I do anything, I need to change these fractions, so I do have both of these fractions having the same denominator. So if I go back here, it says to find the common denominator, put all the included denominators in factored form. So I'm going to go ahead and rewrite these fractions, but I'm going to find the prime factors of each of these numbers in the bottom. I need to find their factors. So 8 is equal to 4 times 2. 4 is equal to 2 times 2. 4 is equal to 2 times 2. So notice in 8, I have 2 times 2 times 2. 4, I have 2 times 2. They both have a 2, or they both have two 2's in common. But 8 has an additional 2. So I'm going to need to tack on an additional 2 over here. I'm going to need to multiply, let me do this, I need to multiply the bottom of this fraction by 2, because I need the bottom of these fractions to both have the same exact factors. Well, notice I can't just multiply a fraction on the bottom by 2. That's going to change that fraction. That's not mathematically relevant. It's not acceptable. So if I'm going to multiply by 2 on the bottom, I have to multiply by 2 on the top. Because if I multiply by 2 over 2, technically that's multiplying by 1, which doesn't actually change that fraction. It just edits the denominator a little bit. So I can rewrite this as 3/8, or 3 over 8, minus 2 over 8. You'll notice, yes, 2/8, if I were to reduce that fraction, it would equal 1/4. So I've written an equivalent fraction, except with a common denominator here. So I have 3/8 minus 2/8. Since I have 3/8 minus 2/8, I'm going to leave the denominator the same and subtract the tops. So 3 minus 2 is 1. My answer here is 1/8. So I had to get a common denominator and then subtract. So here I have 2 over 5 plus 3 over 7. So I'm going to need to find a common denominator. If I were to find the prime factors of both of these numbers, you'll notice both of those are already prime numbers. So I have a 5 here and a 7 here. Well, if I have a 5 here and a 7 here, I'm going to need a 7 over here, and I'm going to need a 5 over here if they are both to be the same. So on this side, I'm going to multiply by 7, and if I multiply by 7 on the bottom, I need to multiply by 7 on the top. And over here, I'm going to multiply by 5 on the bottom. If I multiply by 5 on the bottom, I need to multiply by 5 on the top. See that? Feel okay about that? So if I do that, I get 7 times 2 is 14 over 7 times 5 is 35. Plus 5 times 3 is 15 over 7 times 5 is 35. Now I have a common denominator, and since I have a common denominator, I can add these straight across. I have a 35 in the bottom doesn't change. 14 plus 15 is 29. So my answer is 29/35, or 29 over 35. So that's how I add and subtract fractions if I just have the numbers. I find the factors that I need to include in order to create a common denominator. I get that common denominator, and then I add the tops. So, just as you need to have a common denominator when adding and subtracting fractions, you need to have a common denominator when adding rational expressions. So now if I throw some expressions in here with x's and y's and exponents and things like that, I still need a common denominator if I'm going to add these fractions, or these rational expressions. So let's take a look-see. So it says, find a common denominator for the following rational expressions, then add or subtract and simplify. So reminder, how do I find a common denominator? I'm going to write each of these denominators in factored form. So I have 2x squared, which is 2 times x times x. Here, I'm going to write this in factored form, which is 2 times x times x. Notice these are exactly the same. I already have a common denominator. I already have a common denominator. So I'm going to go ahead. When I have a common denominator, I leave the denominator the same, 2x squared. And then since I'm adding, I'm going to add the tops here. So I have 3x plus 1 plus 2x minus 5. So I can combine these like terms here. So if I'm just looking at the top of this fraction, I can combine like terms. So on the bottom I have 2x squared, and if I add some of my like terms in the top, I have 3x plus 2x, which is 5x, and 1, this is a plus 1, and a negative 5, which gives me negative 4. So my simplified answer is 5x minus 4 divided by 2x squared. See that okay? Feel good about that? Also notice that my excluded values, if I'm trying to identify my excluded values, if I set my denominator equal to 0, because I'm trying to find in my excluded values where I'm going to be dividing by 0. So when x is equal to 0, that's going to be an excluded value, because that would make me divide by 0. Okay, example number 2. I have in the bottom x plus 1 over here and x plus 1 over here. So notice, those are factors. I have x plus 1 as a factor and x plus 1 as a factor. Since they're both the same, that's a common denominator, so I'm set to go ahead and add these two, in this case subtract these two fractions together. I already have a common denominator, I can add these two fractions together. So I'm going to leave the bottom as is, which is x plus 1. Except I'm going to write it over here. I'm going to leave the bottom as is, which is x plus 1. Then the top I have 3x plus 2 minus 2x plus 1. So now we're going to reflect a little bit back to when we were adding and subtracting polynomials. Remember that this subtraction sign, if I want to get rid of these parentheses, that subtraction sign is going to change both of these signs to a negative 2x minus 1. So now 3x and negative 2x just makes x. 2 minus 1 equals a positive 1. So I get x plus 1 divided by x plus 1. Well, x plus 1 divided by x plus 1, if I were to simplify that, I have the same thing on the top as I do in the bottom. So x plus 1 divided by x plus 1, anything divided by itself, is 1. Huh, that's kind of cool. My simplified answer is 1. After I subtracted those two rational expressions together, I got 1. So now if I wanted to identify my excluded values, remember I'm looking at the bottom. Before I completely simplify, I'm looking in the denominator or in the bottom and saying what value of x is going to make the bottom of this fraction equal to 0. Because that's no good. That's a no-go. So if I set x plus 1 equal to 0, I'm going to go ahead and subtract 1 on both sides and get x equals negative 1. So when x is equal to negative 1, that's an excluded value because that's going to make this expression invalid because it'll make me divide by 0. Okay, now let's look at some examples where I don't necessarily have a common denominator. So, for example, here I have x minus 3 over 3x minus x minus 5 over x. So I have 3x in the denominator here, x in the denominator here. I can't do anything here until I get a common denominator. So if I split this up into its factors, I have 3 times x here, and I just have x here. So if I want them to be common, I'm going to need to multiply by 3 on the bottom of this fraction, because I want there to be 3 x's here. So if I multiply by 3 on the bottom here, I better multiply by 3 along the whole top of that fraction. Okay, let's write this out. I have x minus 3 over 3x right here, minus, and if I multiply by 3 on the bottom, I get 3x. When I multiply by 3 on the top, if I distribute that in, I get 3x minus 15. 3x minus 15. Okay, now I do have a common denominator, so the denominator when I subtract these is going to stay the same. And then the numerator, or the top of this fraction, I'm going to subtract. So I have x minus 3 minus 3x minus 15. When I'm subtracting here, if I want to get rid of the parentheses, that minus is going to change each of these signs. So that turns into a negative 3x and a positive 15. Now simplifying there a little bit more, x minus 3x is negative 2x. Negative 3 plus 15 is going to be a positive 12 divided by 3x. So that right there is my final answer. Negative 2x plus 12 divided by 3x. And a lot of people right here are going to be tempted to say, oh, well, I have an x in the top and I have an x in the bottom, so I can just cancel those out. I can't do that because right here I have negative 2x plus 12. I have those being added together. Remember, when I'm factoring, when I'm talking about factors, I'm changing from an addition problem to a multiplication problem. If I had x multiplied by a bunch of stuff up here that was being multiplied, then I could cancel out an x in the top and in the bottom. When I have this addition problem, I cannot do that. I can't just cancel out these x's because this x is being added by this other 12. So keep that in mind. If I want to know my excluded values, I need to know, before I simplify anything, what value of x is going to make the denominator 0. So if I set 3x equal to 0, divide by 3 on both sides, I get x equals 0. So my excluded value is x equals 0. When x equals 0, that expression is invalid because it will force me to divide by 0. Okay, let's look at one more example. I have x over 3x plus 6 minus x minus 5 over 3x minus 6. So notice here, those are really close, but they are not the same. I do not have a common denominator. So what do? I need to write these denominators, I need to write the bottoms here in their factored form. I need to find all the factors. So right now they're as an addition expression. When I'm talking about finding the factors, I want to change it from an addition expression to a multiplication expression. So let's look here. Is there a greatest common factor I can take out of both of these terms here in the bottom, out of 3x and 6? Well, I can take a 3 and be left with x plus 2. So those are my two factors that I would multiply to make the denominator of this fraction. 3 times x plus 2. Over here I have 3x minus 6. I can take a greatest common factor out there too and be left with 3 times x minus 2. See that? See what I did there? So notice both of these expressions have 3's, but this one has an x plus 2, this one has an x minus 2. So in order for them to be the same, let me write these out a little bit bigger. I have 3 times x plus 2. If these are to be the same, I'm going to need an x minus 2 factor on this left fraction. I'm going to need an x plus 2 factor on this right fraction. See that? So I need to add an x, I need to multiply by an x minus 2 over here and an x plus 2 over here. So I need to multiply on the bottom here by x minus 2 and on the bottom here by x plus 2. Okay. Well, if I multiply by those in the bottom, I need to multiply by the same thing in the top. Otherwise, I'd be changing the fraction, and I can't do that. That doesn't make any sense. So, in the bottoms of my fractions, if I'm writing out my fractions again, in the bottom of both of these fractions, I'm going to have 3 times x plus 2 times x minus 2, 3 times x minus 2 times x plus 2. Let me write those in the same order. So I have 3 times x plus 2 times x minus 2 in the bottom over here, 3 times x plus 2 times x minus 2 in the bottom over here. In the top, I need to have x minus 2 times by x. If I distribute x in here, I get x squared minus 2x on the top here. X squared minus 2x. On the right here, I have x minus 5 times x plus 2. So when I multiply those together, boom, boom, I get x squared plus 2x minus 5x minus 3. Sorry, minus 10. And I can combine 2x and negative 5x to be negative 3x. So after some finagling, after some working, I still have the same fractions, but I've added in some factors, so now I have x squared minus 2x divided by 3 times x plus 2 times x minus 2 minus x squared minus 3x minus 10 over 3 times x plus 2 times x minus 2. Now that I have a common factor, a common denominator, I'm going to just rewrite my denominator here, and I'm going to, in this case, subtract the tops, or the numerator. So I have x squared minus 2x minus x squared minus 3x minus 10. Well, if I want to get rid of these parentheses, this negative here is going to change each of these signs. So negative x squared plus 3x plus 10. So now let's combine some like terms on the top of this fraction here. So I have x squared and negative x squared, which makes 0. I have negative 2x and positive 3x, which is just x. And then I have plus 10. So I have x plus 10 in the top, and 3 times x plus 2 times x minus 2 in the bottom. So to subtract these fractions together, I got a common denominator by finding each of the factors that I needed to include in both denominators. Whatever factors I was missing in either fraction, I multiplied on the top and on the bottom, so I didn't change those fractions at all. Then once I had the common denominator, I combined the numerators by either adding and subtracting and kept the denominator the same. So my solution here would be x plus 10 times 3x plus 3 times x plus 2 times x minus 2. And then my excluded values, if we're remembering my excluded values, they would be 2 and negative 2. Because if I put 2 or negative 2 in here into the denominator, it would force me to divide by 0. Okay, That's all I have for you in this lesson. Hopefully, now I want you to rank yourself on how well you understand these things. Being able to find a common denominator for two rational expressions, adding rational expressions, and subtracting rational expressions. I hope that you're able to do those things. If you're confused or if you have questions, please reach out to me. Please let me know so I can help you. I do hope that was helpful, and I hope that you enjoyed that as much as I did.